Hello everyone! Today I'd like to announce a new function. The name of the function is Chatter Canceller, and it has a very curious name. As the name suggests, the function is to suppress chatter caused by machining. Chatter refers to the vibration that occurs between the tool and workpiece. This vibration often results in a machine surface that looks like the image on the right, resulting in poor surface roughness and reduced tool life. By controlling the spindle rotation, Chatter Canceller is used to avoid this problem. Specifically, the spindle speed is increased or decreased. When chattering occurs during machining, we usually adjust the spindle override to avoid it by touching operation panel. It needs to be in front of machine. This function automates such activity by just simple command. The feature of this function is easy programming. It can be executed by inserting two lines of M code between the machining command. I will also briefly explain the argument. S is the argument for spindle selection. S1 selects the left spindle and S2 selects the right spindle. A is the variation amplitude rate. It determines how wide the variation of the spindle speed will be. Basically, it should be set at 10. And if the chattering does not stop, you can increase this factor. B is the variation frequency rate, which determines how often the speed should be varied. Basically, you can set this at 10 and adjust it according to the result. C is the selection of the waveform. C1 is for sine wave, and C2 is for triangle wave. We recommend triangle wave for this. And please don't forget to insert the cancel command. It's pretty interesting feature, don't you think? I guess many customers are interested in price of this function. This function will be available for 30 models and will become a standard feature. Each model has its own schedule, so please ask your sales representative in your country for details. So now, let's take a look at the machining. First, let's try machining without Chatter Canceller. Now today, we will be machining a workpiece with a diameter of 45 mm and a length of 190 mm with the left side spindle. From the sound of it, you can hear that it is vibrating. The length of the pads from chuck jaw is 140 mm. This means that ratio of the diameter to the length is 3.1D. If this value exceeds 3.5D, we suggest center support, and if it exceeds 5D, we often suggest steady rest. So if the value is 3.1D, I think we are not sure whether to use those or not. That's why it's interesting to use Chatter Canceller. So this process is a bit long, so I'll skip. So this is the end of the machining. If you look at the surface, you can see that chattering has occurred. The next step is to turn on the Chatter Canceller. The sound is already different. You can see that the odd cutting sound has disappeared. Of course, not all chattering can be solved, but I think the future of this function is easy to try. For example, if the chattering is controlled by Chatter Canceller, we can find out it's a problem that can be solved by changing the spindle speed, and then we will start to find the optimal conditions. Skip a little bit, finish the process. Now, let's see how the machine surface actually looks. It looks better than before. Now, when we zoom in, the result is like this. With the Chatter Canceller on, Markov turning appears clearly. I think it's a good result. Today I use the upper left turret of NTY3100 as 3-turret machine. All turrets have Y-axis interesting machine. If you look like this video, please click the like button, and if you haven't registered yet, please subscribe.